Hello and welcome to the second video on the GCSE Physics for AQA course on this space topic, which is all about the solar system and orbits. So first of all, we really need to appreciate what we mean by a solar system. And a solar system can be defined as a star, in our case the Sun, and all the objects which orbit it. So here's a quick, not to scale representation of our solar system with the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune all clearly labelled. But there are also a couple of labels for a couple of smaller objects within our solar system, particularly Pluto and Ceres. Those two objects are what we now define as being dwarf planets. Up until not that long ago, actually, Pluto was defined as a planet, but when we consider definitions and we consider other objects within the solar system, more and more objects similar to Pluto are being found that would make the definition of Pluto, and Pluto is, to be honest with you, comparable in size to our moon. So it didn't make a lot of sense to have an object that was as far out as Neptune, or more accurately, further out than Neptune, be defined as a planet when it didn't fully obey quite all the rules that we need for a planet. What are those definitions? What is the definition of a planet? A planet is a large object in orbit around a star, must be round or at least nearly round, and must be large enough not to have any other debris in its path. Now, by debris we mean asteroids or lumps of rock, and over the course of the formation of our solar system, the major 8 planets that we talk about have removed most of this debris from their paths as things have gone on over the thousands or millions of years that it took for the early planets to form. Pluto, as I mentioned, is defined as a dwarf planet, and here we've got an image of Pluto. It's a planet-like object that orbits the stars but does not always match all the criteria for the planet. So in the case of Pluto, it's not exactly large enough, and it also does not hasn't cleared its path of debris. There's a lot of other things that share orbital paths with it. Therefore, we define it as a dwarf planet. Satellites. Another definition we need to be aware of. Now, there's 2 key forms of satellite. Any object in orbit around another more massive one, that is to say a more massive object with more mass. So artificial satellites are the man-made ones, and the Earth has got a large volume of these which provide all kinds of function. The image here is of the Hubble, but we use them for pretty much day-to-day communications, satellite communications, mobile communications, observing and predicting the weather, as well as observing and looking into space, just like the Hubble telescope. And the natural ones, like the moon and planets, are all natural satellites of the much more massive objects. In the case of the moon, it's a satellite of the Earth. In the case of the Earth, it's a satellite of the Sun. So we need to know and be able to discuss a lot more details about orbits. Orbits happen due to the force of gravity. Now, in the process of forming a solar system, the cloud of gas and dust orbit that is around a star is typically going to be in motion. And as the planets all coalesce, they still are held in orbit around a star by the force of gravity. So at any given moment within its orbital path, the planet has an instantaneous velocity that is at right angles to the force of gravity that's acting on it. And it's that combination of the velocity in one direction and the gravitational force at right angles to it that leads to a circular, or at least near circular path. Strictly speaking, the paths are elliptical, but for the purposes of your GCSE discussions, you can call them circular, and that will be perfectly acceptable. However, one thing you do need to appreciate, particularly at the higher tier level of things, is how the distance from the star will affect the speed of the orbit. By size of orbit in this context, I mean the radius of the orbit from the center of the star. The closer the object is to the star, in this case I've represented that one with a red dot, the faster the object is going to have to move in order to be able to orbit or maintain a circular orbit. The further away, represented by the green dot in this diagram, the slower the orbit can be. As you can see from the diagram I've represented here, the smaller object has to orbit many more times in a given period before the green one has completed one complete orbit itself. And this is what we see within the solar system. Mercury and Venus take a lot less time to go around the sun. Their years are a lot shorter than one Earth year. And as you go out further than that, Mars and the other planets have got much longer years because they take a lot longer to orbit around the sun.